Hello, welcome to the show. It's me, JP. Time for another episode of JP's Product Pick of the Week. Thank you so much for joining here today. First thing I will do is let you know where to go. If you want to get a jump start on this thing, head on over to that URL right there. It's product ID 5188. You can also use that QR code if you point your camera at it and do the thing. That is the product page for this week's product pick. And you can watch this show from inside of there. We broadcast this very YouTube stream, in fact, from the product page. And you can get a jump start on throwing it into your cart at a super great discount. This week it is 50% off. Excuse me, it is 50% off. That was a little clearer. And you don't need a coupon code or anything like that. If it's something you want, throw it or up to 10 of them in your cart. No resellers allowed. And that price is going to be good until about a few minutes after the show. Get a little bit of a grace period there. But really, the discount applies during the show. And you'll get it for that price without a coupon code. Just buy it. And I'll tell you what, before I go any further about this, this week's product pick actually is a revised version of a popular product of ours, and I'm going to jump back in time and have Lady Ada tell us about the original and then the updated versions. So take it away, Lady Ada.
This is a precision real-time clock.
This clock thing.
We're going to be making a featherwing out of this as well. It's coming soon, but this is a little breakout for the DS 3231. It's a high precision real-time clock. What's neat about this is it has the crystal that normally would come with your real-time clock, the little 32 kilohertz crystal. It's inside the chip, and there's a temperature sensor, and the temperature sensor measures how the temperature is moved up and down, and uses that to compensate the crystal so that it can keep time very, 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 very precisely. I think it's like 2 parts per million precision. It's something ridiculous. It's pretty much the most precise real-time clock we've seen, outside of a temperature compensated clock standard from like cell towers. People always pick those up on eBay. Those are totally awesome. But if you want something that can fit on your breadboard and off a coin cell, this is your best bet. It's very small and cute and breadboard friendly. So if you need precision real time, this will work. It has this battery backup capability. It's all good.
Yeah.
We didn't have breakouts for these RTCs before, but these are now the STEMMA QT versions. So we've got two. We've got this, which is the DS3231, which is a high precision, temperature compensated crystal real-time clock. This is kind of like the finest of the fine. This is like the truffle of RTCs.
See, this is how we tying it together.
High quality RTC over I2C, and on the back there's a coin battery holder. And then if you're like, well, I don't want that, I'm okay with truffle oil, which doesn't actually contain truffles. Yeah. The PCF 8523, I think this is a perfectly fine real-time clock. Great for data logging, maybe not for clocks, just because it will lose a few seconds, a second or two a day compared to the DS3231. But for many purposes, the PCF is perfectly fine. Also has the coin battery holder on the back, plug it in over I2C. Now coming with STEMMA QT connectors, it just makes it really easy to plug and play these into an existing system because it uses our I2C connections.
You can do this.
You can do either one, and it's you can pick and choose, right? You can start with one and then decide you want higher precision or lower. Switch over to the PCF. Of course, we have Arduino and CircuitPython code for both of these because they're just STEMMA QT versions of our existing breakout. These are kind of my two favorite RTCs. You've got the high quality and the budget quality. Both are very good.
Budget, high quality.
That's it.
Yeah, that's right. So here, check it out. There it is sitting right there. Look at that delightful little breakout. This is the product pick of the week this week. It is the DS3231 Precision Real-Time Clock Breakout. This has I2C to communicate with your microcontroller. It has a battery backup, so it's always going to keep track of the time, even when your project is powered down. And it has the STEMMA QT connectors to make it plug and play with your microcontroller projects. It just couldn't get easier. This is the one you want if you are making clocks. So first of all, let's jump over to the product page and check it out. So there it is. Look at this. Today, and today only, this is, I don't know, maybe one day we'll make it this price again. But today, very special today, it is 50% off. That's right. It is $6.95 right now during the show only. So throw some in your cart if you have any clock aspirations. Maybe watches too if you want to make some big, huge cyber watches. But great for clocks. It is a temperature compensated crystal. So the crystal is sitting there oscillating, but the temperature can change that oscillation. So it has a temperature compensation, so it can adjust the time that it's reporting based on any changes in temperature, which is fantastic. All it does is report back to your microcontroller a really nice struct of the time, or message of the time. So it's the date and the time. I'll show you all of that in code in a second. But when you're working with it, it's really easy. We have an Arduino driver for it. We have a CircuitPython driver for it. So you can plug and play with your project, get those libraries, and then with some sample code, get up and running really quickly to build your own clocks. So how about first of all, before I move on to that, let's take a look at the product Learn Guide. So if you take a look from the project page and scroll down a little bit, you'll get to this little Learn section. You can see we have a couple of clock projects that use this, and then we have the main Learn Guide here. So there's a nice set of photos. You can see the back there. This uses a CR1220 coin cell. Just plop it in there, and that will back up your time for a long, long time. You can check out the pinouts on the pinout page here. You can see there's the previous version. It's the same, other than we've now got the nice convenient STEMMA QT. Also, look at that neat, I like this little cutout, little notch that Lady Ada did on the board design there. It's really snazzy looking. It has the pins that you would expect both as I2C on STEMMA QT and on the main row. In addition, we also have the battery pin. So this is if you wanted to supply that power somewhere else. We have the oscillator output. So there's a 32 kilohertz oscillator output you could use for something else on the microcontroller. There's a square wave output. Optionally, it's an interrupt, and you can use that to read things on your microcontroller as well. And then we have this pin. It's labeled as reset, but really one of the it's not really a reset like a board reset, but what you can use it for is measuring when we switch from main V-in power to battery. So you can have a sense that you've lost power and gone to battery backup in case you need to log that to be able to calculate any needs of changing a battery out at some point, depending on your use. If it's a remote thing, you might want to get messages about that sort of thing. So you can then take a look. We have the assembly page, which is really just if you're going to be soldering headers to it. Otherwise, it's just plug and play with the STEMMA QT. There's a page here on Arduino Usage with some sample wiring diagrams, so you can plug that together and run the RTC lib library and some sample code. And then we also have the CircuitPython page. Again, some wiring diagrams for that. Easiest way is going to be just plugging in STEMMA QT cables. And then we have the library you want to get there. It's the DS3231 library. You can just use circup to install that if you want. And then we've got some examples of the code here. So you can see, actually, we'll take a look at some of the code examples right here because they're nice and simple. What you do is import the board for pin definitions, and you'll set up an I2C bus. And then you will import the DS3231 library, and then you can set up your clock object or your RTC object here on I2C. And then if you want to find out the date time, you simply ask for this value, DS3231.datetime, and that'll report it back with these separate pieces of data. So you get the year, the month day, the hour, minute, second, weekday, so Monday through Sunday, year day, 1 through 365, 366, depending on leap years, I guess, and then daylight savings. I don't think we use those last two in our library, so I'll show you a practical example in a second. But here you can see setting the time, so DS32 date time equals time, and then struct time. Here it was set to 2017, January 1st, and these times and days of the week. So I'm going to now jump to the practical example here. So let's go into my overhead cam view right there. And so what you can see here, I'm going to go ahead and unplug my Oh yeah, that was already unplugged, okay. So I've got a feather under here with a STEMMA QT cable, and I'm gonna plug that STEMMA QT cable into my real-time clock, just like so. And I'm just gonna hang it off of this screw right here so it stays put. That's good enough. And then I have this feather connected up to one of these nice sharp memory displays just because they look really good. So I'm gonna try to set that into anti-glare angle mode there. That should work. And let's plug this board in. Is that the power? Okay. So you can see here, it's going to power up, and then it is immediately going to grab the time off of the chip. So I set this chip yesterday while I was setting up this project with the time, and it has just been sitting there continuously running and calculating that time. So it just updated, and now here we are, 1:13 and 30 seconds. This is accurate to the second easily. If you take a look, in fact, at my computer's web page there, I have the NIST time up there. So these are at, let's see, in my time it's 1:13 and 50 when I switch over, boom. So we get nice accurate time. I don't have to worry about when I unplug this, it keeps the time thanks to that little button cell battery. If I turn off this, I've just unplugged this cable, you can see it takes a little while for that display to fade. Plug it back in. When it restarts, it's going to be lockstep in time. So it should be at 1:14 and about 20 seconds when this thing starts back up. And there we go, 1:14 and 20, 22, 23. So looking at the code here, let me jump to my circuit Python code.py. And here are the key things. So like we looked at before in the simple example on the Learn Guide page, I'm importing the DS3231 library. I'm setting up I2C, and then I'm creating this object. I named it RTC here. The RTC object is the Adafruit DS3231 on I2C. And then T is the variable I'm setting up for grabbing that date time message. So when I ask for T, it's just, hey, RTC, give me the date time. Then we have a nice convenient day list here that we can use to grab nice names. And you can see here at the top of my screen, I'm listing there Tuesday, 2/13/24. It's the month, day, year, how we do it in the US. And then this little section here is how we set it in the first place. So I only needed to do this once, but what I did was set this to be true and then typed in the values. Through trial and error, found out it took me 2 seconds, I think, when I hit save for it to restart. So I timed that looking at the NIST clock so I could nail it to the second. And then we changed that back to false and resave this, and that just means if the board resets or gets plugged, it doesn't just keep resetting to that time. So that's something to watch for. And then I'm doing some, we'll take a look at these in the main loop, but I'm setting up some labels on my display that show me the date and the time. So let's look at that in the main loop here. You can see every time the loop runs, I grab the date time off of the chip. I'm also doing some stuff to compensate for 24-hour time and making my year just be the last 2 digits. And then this right here, I'm setting the, scroll over, this piece that prints up here to both to my REPL and to the screen says, and in fact, hold on, let me reset that REPL so you can see that updating. So when I print that or print that to the screen, I'm grabbing this from the format. The days is based on that list there, and asking the question of the real-time clock, what is the TMW day? That's the weekday or day of the week. What is time month, time month day, and that nice year display, which is based on, if you look over here, the TM year, and then I'm subtracting 2000 from that. And then for the time, we just ask for nice hour, which is TM hour minus 12 if it's past noon, TM minute, TM second. So straightforward to ask for it. It just reports it back to you. It does all the tricky stuff in the background of keeping that thing accurate for you. And so that is the just slight adjustment I did to the example code in the Learn Guide and in the library written by Lady Ada, so you can go and grab that. And coincidentally, as I was working on this, there was a guide published. that I'll bring up here. Noe was working on, let me bring that up, a really beautiful clock project. Look at that. So this uses a large 7-segment display with 4 digits in it, a sort of mid-century modern style 3D printed case. There's a really nice use of the rotary encoder with the push button to be the interface for adjusting the time. And on the inside there is our good friend, the DS3231 Precision Real-Time Clock. So great fortuitous timing, pardon the pun. That guide just came out, just published today. You'll see more about that, I think, tomorrow on the 3D Hangouts, as well as on Ask an Engineer, maybe Show and Tell. But this is, if you take a look at the code, very similar stuff here, written by Liz, doing some similar adjustments for the time. But also this has alarm, or if not alarm, as dimming function. I'll let them talk more about it tomorrow. But really cool clock project using this, this very real-time clock module right here. So let's see, what else? Any questions in the chat? Let me have a look over here. By the way, I should say, if you're wondering where the chat is, you can head on over to our Discord. That's at adafruit.it/discord. Or you can also hop into the YouTube chat. Dave Odessa says, I got some flowers for Valentine's Day. You can see them back there. I actually had to buy those for myself, sadly, but I was taking some macro photos for a guide. So, but I'll pretend, yeah, I'll pretend they're Valentine's Day. How about that? So let's see. Half off for these boards is a steal, says squid.jpg. You're right. It's a great price. Any other questions? This display does look sharp. Look at that. Love that display. Look at that. Beautiful. All right. I think that covers it. Any other questions, let me know. DJ Devon3 asks, how often would it really need to be resynced with something like an NTP sync? You know, that's a good question. I don't know. You know, it's not even losing a second a day, according to Lady Ada there. You can check out the data sheet if you head over to the Learn Guide. There's a link on the pages here for downloads. You can go both to the product page and to the data sheet. So if you take a look at those, here's the product page for it. And they say highly accurate. And I don't know, I don't know what that means. So I don't know what the milliseconds a year you lose or what. Let's see, here it says, yeah, they express parts per million, accuracy plus minus 2 parts per million at 0 to 40 degrees centigrade. I do not know how that translates to timekeeping. So good question. I will at least follow up in the chat if I get an answer to that. But we'll just say it is super, super, very, very highly precisely accurate, technically speaking. All right. I think that is going to do it then. So let me, I'll keep that clock down there and grab this. Don't forget, you can go right there if you want to go and grab one. Just head to that QR code, that URL, throw some in your cart. The price is going to go back up after the show, so this is the time to grab some if you want them, if you have any clock aspirations. So that right there is my product pick of the week this week. It is the DS3231 Precision Real-Time Clock Breakout with STEMMA QT. For Adafruit Industries, I'm John Park, and this has been JP's product pick of the week. I will see you next time. Bye-bye.